Hello, dear students. We are continue our lessons. Today is discipline interchangeability, standardization, and technical measurements. And today is laboratory work number 6. Write down to your notes the theme of our laboratory work: calculation of a linear dimensional chain by the method of full interchangeability. Calculation of linear dimensional chain by the method of full interchangeability. And write down the example and the task of the laboratory work number 6. An assembly drawing of the mechanism number 2 with the nominal dimensions of the surface of the parts. A suffix 1 is equal 96 millimeters. A suffix 2 is equal 54 millimeters. A suffix 3 is equal 3 millimeters. A suffix 4 is equal 140 millimeters. A suffix 5 is equal 6 millimeters. And the size of the initial link delta A is equal, and delta A equal A suffix 0, its initial link or closed link. And this link is equal 1 upper limit deviation minus 0.150 and lower limit deviation minus 0.700. It's tolerance fields of the initial link. So A suffix 0 is equal 1. And what we must do? Construct a scheme of the dimensional chain of a given mechanism with the designation of increasing and decreasing links. Second, according to the given tolerance of the output link, determine the tolerances and maximum deviations of the constituent links by solving the maximum and minimum solution of the direct problem. When determining tolerances for component dimensions, use the method of 1 IT grade. And 6.3, check the results of the calculation of the dimensional chain by solving the inverse problem. And we start the calculation. For assembly number 2, you can see a sketch of the assembly drawing number 2 on our slide. We have links A1, A2, A3, A4, A5, and initial link delta A. For assembly number 2 on figure 6.1 with nominal dimensions of parts surfaces, A1, A suffix 1 is equal 96 millimeters. A1. A suffix 2 is equal 54 millimeters. A suffix 3, you can see on the figure, A suffix 3, it's equal 3 millimeters. A suffix 4, 140 millimeters. A suffix 5 is equal 6 millimeters, and the size of the initial link is clearance between parts. A suffix 0, it's equal, or delta A, it's equal 1 millimeters with upper limit deviation minus 0.15 and lower limit deviation minus 0.7. Build the scheme of a dimensional chain. You can see the scheme of the dimensional chain on the figure 6.2. And now we can see the links A suffix 1. Determine the length of the dimensional chain increasing and decreasing. So A suffix 1, it's increasing links. A suffix 2. It's increasing links too. And A suffix 3, it's decreasing links. A suffix 4, decreasing link. A suffix 5, decreasing link. And initial link delta, or A suffix 0, A suffix 0, or delta A. It's our clearance. So once more time, A suffix 1 and A suffix 2, it's two links. All these links increasing links. Other links, A3, A4, and A5, it's decreasing links. Why A suffix 1 is increasing links? So increasing links, that is the links that when its link increasing, the clearance, the initial link, increasing too. If decreasing links, for example, A3 will be increasing, the initial link will be decreased. So A3 will be decreasing links. A1 and A2, it's increasing link. A3, A4, A5, it's decreasing links. The arrow to the left, it's decreasing link. Increasing links, the arrow to the right. Write down to your notes the scheme of dimensional chain. This scheme is for assembly number 2 from the figure 6.1. Let's check the correctness of the construction of the dimensional chain. A suffix 0 initial link is equal the sum of increasing link minus the sum of decreasing link. So increasing link, it's A suffix 1 and A suffix 2 from previous slide. A suffix 1 and A suffix 2, it's increasing link. So the sum of increasing link A1 and A2 minus the sum of decreasing link A3, A4, and A5. And what we have? We have A suffix 0 initial link will be equal 96, it's A suffix 1, plus 54, it's A suffix 2, minus 3 plus 140 plus 6, it's A suffix 3, A suffix 4, and A suffix 5. It will be equal 150 minus 149, and it will be equal 1 millimeters. In our task, A suffix 0 equal 1 millimeter. So our dimensions chain is correct. According to the given tolerance of the link of the initial link, we determine the tolerances and maximum deviations of the component dimensions by the method of solving the maximum and minimum using the method of 1 IT grade. It's method of 1 IT grade. Tolerance of the initial link. Initial link is A suffix 0 and tolerance it's T A suffix 0. Will be equal upper limit deviation of the initial link minus lower limit deviation of the initial links. Minus 0. Let's see our task. Upper limit deviation and lower limit deviation of initial link. So it will be equal minus 0.15 minus and one more minus 0.7. And it will be equal 0.55 millimeters or 550 micrometers. And it's equal to the sum of tolerance field of all links of the dimensional chains, except initial links. N, you can see N plus P. N, the number of increasing links, and P, the number of decreasing links. N plus P is all links except initial link. So T A suffix 1 plus T A suffix 2 plus T A suffix 3 plus T A suffix 4 plus T A suffix 5 will be equal 550 millimeters. Tolerance of any size or link is equal to tolerance is equal A multiplied by E. In this formula, A number of tolerance units and E unit of tolerance. Therefore, T tolerance field of initial link will be equal A suffix 1 multiplied by E suffix 1 plus a suffix 2 multiplied by e suffix 2 plus a suffix 3 multiplied by I suffix 3, a suffix 4 multiplied by I suffix 4, and plus a suffix 5 multiplied by I suffix 5. Therefore, the problem is solved by the method of one IT grade, and the value of a depends only on the IT grade number. Therefore, a suffix 1 will be equal a suffix 2, will be equal a suffix 3, will be equal a suffix 4, and a suffix 5. And let's it all parameters will be equal a suffix m. So then tolerance field of initial link of a suffix 0 will be equal a suffix m multiplied by sum of the I from I suffix 1 to I suffix 5 multiplied by this sum. Where do we find the value of AM? We can find the value of AM. AM will be equal from this formula. This sum, it's the sum under the line, and above the line it's equal T A0. It's tolerance field of initial link. TA0 it's equal T delta A. It's the same parameter. So if we know AM, we can find the IT grade number. Calculate I, the units of tolerance for each link, and the results of the calculation are summarized in table 6.1. Table 6.1. So we use the formula to calculation I. It's 0.45 multiplied by this square d suffix m plus 0.001 multiplied by d suffix m, where I is the unit of tolerance which expresses the dependence of the tolerance on the size in micrometers. D suffix 1 is a geometric mean of the limit values of the interval of nominal dimensions. It is calculated by the formula that you can see on our slide. In this formula, d suffix minimum and d maximum are the smallest and largest limit values of the interval of nominal dimensions. On the next slide, we can see these intervals. You can see the nominal dimensions of d. For example, d minimum it's 3, d maximum it's 6. Or, for example, d minimum is 50, d maximum is 80. It's interval of nominal dimensions. Next interval from 80 to 120. Then from 120 to 180. It's all intervals. So d suffix minimum, it's first value of this interval, and the second value of this is 180, for example. In previous slide. We can find these parameters, d minimum and d maximum, for each link. For example, a suffix 1 is equal 96 millimeters. For 96 millimeters, we use interval 96 millimeters from 80 to 120 millimeters. So d minimum will be equal 80 millimeters and d maximum will be equal 120 millimeters. When we use the formula on the slide, it's formula 1 and formula 2. When we use formula 2, we can calculate d suffix m. It's the geometric mean of the limit values of the interval of nominal dimensionals. Then we use this parameter, this value, and using the formula 1, we can calculate I. And then I, we write down to our table 6.1. For the links with a suffix 1 with nominal dimension 96 millimeters, I suffix 1 will be equal to 2.22 micrometers. Then we continue our calculation. A suffix 2, 54 millimeters. 54 millimeters. For 54 millimeters, its interval from 50 to 80 millimeters. So d minimum will be equal 50 millimeters, d maximum will be equal 80 millimeters. And then we can calculate, using this d minimum and d maximum, we can calculate d suffix m. Then we use this d suffix m in the formula 1, and we can calculate I. And this I, it will be I suffix 2 for A2, 54 millimeters. And we continue our calculation for A suffix 3, A suffix 4, and A suffix 5. For A suffix 3, I3, it's equal 0.72 micrometers. For A suffix 4, I suffix 4 will be equal 2.42 micrometers. And for A suffix 5, I suffix 5 will be equal 0.77 micrometers. So we know all parameters of I for all links. Then we can calculate parameter A suffix m using the formula from previous slide. Let's look at the previous slide. We can calculate A suffix m. We know that this parameter, and now we know the sum of I suffix 1 from I suffix 1 to I suffix 5. And what we have? I suffix 1, 2.22, I suffix 2, 1.78 micrometers, I suffix 3, 0.72, 2.42, and 0.77. And we know that tolerance field of A0 is equal 550 micrometers. And then we can calculate A suffix m. A suffix m will be equal 69.5 micrometers. Micrometers. So 69 and 5 micrometers. By A suffix M, choosing the nearest IT grade, having determined according to the tables of the ISO, the values of tolerance of component size in accordance with the nominal value, perform a test according to the formula. Formula number 1 on this slide. So 69, it's between 64 and you can see AM, and 69 is between 64 and 100. We can choose IT10 or IT11, IT grade. According to the found values of AM, we take the closest standard value. Closest standard value, it's 64. We have 69, the closest standard value is 64. So we choose IT grade IT10. If we choose 100, then IT grade will be equal IT11. But now we choose the nearest. AM, it's nearest standard AM, 64 for IT grade 10. So we choose IT grade 10. For closest standard value A64 according to the directory with which corresponds to the IT grade of IT10, assigning the tolerances of the components of the dimensional chain according to IT10. We use the same table and we use IT10. Where is our IT grade? IT10. So we use this column to choose the tolerance field of each link. The first link, what's the dimension of the first link? A suffix 1, 96 millimeters. 96 millimeters. So for 96 millimeters, it's between 80 and 120 millimeters. For 96 millimeters, tolerance field will be equal 140 micrometers. You can see 140 micrometers. For the second link, 54 millimeters. We use the same table. And for 54 millimeters, it's between 50 and 80 millimeters. For this link, we use tolerance field 120 micrometers or microns, 120. And what we can see on the next slide, we can see for the second link, 120 millimeters, it's tolerance field of this link. And tolerance field for the third link, for the first link, and for the fifth link, we choose using the same table. all this sum will be equal 508 micrometers. Because T tolerance field of initial link delta A not equal (508 micrometers), tolerance field of T delta A, what we have, the numerical value tolerance field T delta A is equal 550 micrometers. 550 micrometers. So 550 550 micrometers is not equal 508 micrometers. So we accept the special link if we have, because it's not equal, we accept the special link A4, the tolerance of which will be non-standard. A1, 2, 3, 4. We have a tolerance field, standard tolerance field for A4, it's 160, but we can calculate non-standard tolerance field for this special link. We calculate the non-standard tolerance of the special link. Tolerance field of special link A4 will be equal tolerance field of initial link minus the sum of tolerance fields increasing and decreasing links minus 1, except special link. So T suffix 0, it's equal 550 micrometers. The sum 140 plus 120 plus 40 and plus 40. Let's change the color. 140 plus 120 plus 40 and plus 48, except 160. It will be equal 348. And 550 minus 348 will be equal to 202 micrometers. It's non-standard tolerance of special link. To determine the maximum deviations of the links, we classify them into those that cover and are covered. A suffix 1 and A suffix 2 conditionally refer to the holes and assign tolerances as for the mean holes. A suffix 3, A suffix 5 conditionally refer to the shaft and assign tolerance for the main shafts. And T suffix and A suffix 4 is special links. Calculate the lower limit deviation of the special links, of the special link. Lower limit deviation EI of special link A suffix 4, calculating using the formula on your screen. The sum of upper limit deviation of increasing links minus upper limit deviation of initial link and minus the sum lower limit deviations of decreasing links. Where we find these parameters? From the table 6.2. For links A1 and A2, we choose upper limit deviations and lower limit deviations, like for the main holes. And for the main holes, lower limit deviation will be equal 0, and upper limit deviation will be equal tolerance field plus 140. And the same parameters for A suffix 2. Lower limit deviation will be equal 0, and upper limit deviation will be equal tolerance field. For the special link, it's special link for the link A suffix 5 and A suffix 3. We choose upper limit deviation and lower limit deviation like a main shaft. For the main shaft, upper limit deviation will be equal 0, and lower limit deviation will be equal minus tolerance field. So 40, it will be minus 40. 48 will be lower limit deviation, will be equal minus 48. So we know all ES and EI for the all links except special link A4. We don't know EI, lower limit deviation A4, so we can calculate it using this formula. So we know upper limit deviation of increasing links plus 140 plus 120. Then minus upper limit deviation of initial links. We know it's from the task minus 150. And lower limit deviations of decreasing links, it's minus 40 and minus 48. Minus 40, minus 48. And when we calculate this formula, we find the lower limit deviation of special link A suffix 4. It will be equal 498 micrometers. 498 micrometers. Then we can calculate the upper limit deviation of the special link. Its tolerance field of special link, tolerance field of special link accepted 202. On the previous slide, we find this parameter. (202 micrometers). It's tolerance field of special link. So 202 plus lower limit deviation of special link 498. And what we will have, we will have plus 700 micrometers. It's upper limit deviation of special link plus 700 micrometers. So we know all parameters. of our links from the dimension chains. And the last what we must do, we must to check the correctness of the calculation by determining the lower limit deviations of the initial link using the formula. Lower limit deviation of initial link will be equal this using this formula we can the sum of increasing lower limit deviation of increasing links, lower limit deviation, first increasing link, lower limit deviation 0, second lower limit deviation 0, 2. So 0 plus 0, and then minus upper limit deviation of decreasing links. Upper limit deviation, let's change our color, the blue. Upper limit deviation of decreasing links. First decreasing link, A3, 0. A4 plus 700 and A5 ES 02. So 0 plus 700 plus 0. Zero plus 700 plus 0. It will be 700. So 0 plus 0 minus 700 will be equal minus 700 micrometers. It's lower limit deviation of initial links. Let's see this parameter from our task. In our task, the lower limit deviation of initial links minus 0.7 millimeters or 700 micrometers with minus. So what we can say? We can say that minus 700 micrometers, the problem is solved correctly. So now you choose your variant of this task and start to calculating using our example that you can see in our presentation. If you have the questions, you can write it to our Telegram group, to our forum on the course, and then when you finish, send it me to our course or Telegram group. So start your work using your variant of the task.